Hello. In this video I'm going to talk only about the intersection that we can see in the shape of Klein bottle, and it's similar to the intersection that we find also in the Mobius strip if we represent its shape in 2 dimensions. So first, as a definition, Mobius strip and Klein bottle are non-orientable 2-dimensional manifold. For the Mobius strip, it is a 2-dimensional manifold, but we need 3 dimensions to get a clear image of its shape. But for the Klein bottle, it's also 2-dimension manifold, but we need 4 dimensions to visualize its shape with the clear perspective. So here I'm going to talk about these 2 manifolds from the point of view of a fiber bundle, because both of them they are fiber bundles of a circle as a base manifold. So let me see here how to represent. So for example, if we consider a circle as a base manifold M, and we associate to each point a line. So for example, this is P, this is the fiber FP. So of course we will get as a total space a cylinder. So the cylinder A is a total space, and we have a natural projection from this total space to the base manifold. The elements in total space is located by X. X is an element from the point M, and U is an element from the fiber. X is in M and U is in Fx. Okay? So that was just the definition of the fiber bundle. In this case, this is a vector bundle because the dimension of each fiber is equal to 1. It's a vector bundle of rank 1 because the fibers here are vector spaces. Now I'm going to use a specific construction to get the fiber bundles of a circle. For example, instead of taking this circle as a closed curve here, I will choose a segment, but this is the same point. It's like we cut the circle to get a segment and see how things look like locally in this construction. So if I consider this is my circle and I associate to each point a line, okay, I will get the same thing when I join these 2 sides. I will get the same total space, which is a cylinder. Okay, it's clear. So if I join these 2 sides, I will get the total space. So this is the construction that I'm going to use to get the Klein bottle and Mobius strip. So consider first my circle, and if I associate to each point a new circle, so these are the fibers. For example, this is FQ and this is the point Q. So if I associate to each point a circle, and then when I will join the ends of this segment, I will get a torus. Okay, T2. So torus is also fiber bundle of the circle. The base manifold is the circle. Okay, so by the same thing here, after I consider this from X, Y, and Z, I will take the segment in the plane YZ. So this is my circle AA, and I will associate to each point a line, but I'm going to twist these lines around the y-axis. So this is the trick that I have to use. So when I twist this line, they will look like short. Okay, for example, this line is perpendicular to the plane YZ. That's why I put only a point. Okay. So after I join this fibers, I collect all of them, and I join the ends. I will get the Mobius strip. It's clear here, the Mobius strip. So you can see the intersection in the middle. Sorry for my cam is not good. It doesn't work. Let's take a picture clear. So you can see the intersection in the middle here. So the intersection of the Mobius strip came from twisting the fibers around the y-axis. Okay, twisting around the y-axis. So I'm going to do the same construction to get the Klein bottle. So remark here, this is again the from x, y, and z, and this is my circle A. I will associate to each point, for example, the point A, I will associate to it the circle, or the fiber FA. This is the fiber FA. It is a circle in the plane XZ. It is a circle in the plane XZ. Okay? And I'm going to twist these circles around this X axis. This time I'm going to twist around this axis, X. So this is the first point. For example, the second point, it will be a little bit this way. Let me orient the circle. Okay. So this is, for example, the point Q. Okay, so this is the fiber FQ. And this is the point A, the last point. Okay? So I associated to each point from the circle AA, because this is a closed curve. Okay, you have to imagine this as a closed curve. I associate to each point a circle, and I twist these circles around the x-axis. Okay. Now I will collect all of these circles this way, but we have to be a little bit careful for the orientation. Okay, so you can see here an intersection of the circles. So after I join the two sides, I will get a shape in this way. So this is the Klein bottle, and that mysterious intersection comes from twisting the circles around the x-axis. So you can see here that it's impossible to see the total space in 3 dimensions. We need 4 dimensions to get off this intersection. So it's the same thing for the Mobius strip. Mobius strip, we need 3 dimensions to see the twist of a line, but for the Klein bottle we need 4 dimensions to see the twist of the circles.